Hi folks, we're going to take a look at 83B from page 447. So they give us this triangle here and they want us to find this length h, essentially the height of the triangle. All right, now there's a way to solve this by just working with right angle triangles, but it would involve having to solve a system of equations, so it'd be more steps, much longer. So what I'm going to do is going to use the fact that we have our sine and cosine laws to work with non-right triangles. All right, so let's see what we need to determine h. Well, we have the angles in either of these two right angle triangles. So if we could find a side length, then we'd be able to solve for h. And the idea is to find a side length that's in the right angle triangle, but also in the larger triangle. And I see that this side length, which I'll call x, is in both the large triangle and the right angle triangle. I could have also solved for this one out here. Okay, so this will make it just a two-step problem. So let's solve for x here. So since I have these two angles, I have this side length. So remember, to determine whether I use sine or cosine law, I ask myself, do I have an angle opposite side pair? Well, I know this side length. While I'm not given this angle, I can solve for it because I know the other two angles in the triangle. So this is going to allow me to use the sine law. So let's start by taking 180 and subtracting 47 and 42, and that leaves me with 91. So this is actually very close to a right angle triangle, but it's not exactly a right angle triangle. So I can't use sine, cosine, or tangent on the large triangle. All right, so now I have enough information to solve for x. So remember two versions of the sine law, the one where the side length is at the top, the other one where the angle is at the top. Since I'm looking for the side length, that's what I'm going to put in the numerator. So I have x over the sine of its opposite side, so in this, opposite angle, which is 42 degrees, equal to this side length here, 200 over the sine of its opposite angle, which is 91. All right, so let's solve for x here. So what do we have? So I'm just going to multiply the sine 42 to the other side. So 200 times sine 42 equals, and then divided by sine of 91. Okay, so we have 133.85. So x is 133.85. And now that I have this side length, I have enough information to work with that right angle triangle. So since I'm looking for the opposite side and I know the hypotenuse, I'm going to use sine. So sine of 47 degrees is equal to the opposite side, the one I'm looking for, h, divided by the hypotenuse, which is the one I just found, 133.85. Okay, so h is equal to, I'm just going to multiply the 133.85 to the other side of the equation. So I already have it in my calculator, so times sine of 47, and that's 97.89, or we'll just say 97.9. 97.9. And what were the units? If I look back at the textbook, the units were in meters. Okay, so much easier than if I had tried to solve this using only right angle trigonometry. All right, so let's just recap. Step number one was to realize that because I needed to find this length h, I was going to have to work with one of these right angle triangles, but I didn't have enough information as I only had an angle in each. So I needed to find a side length, which was not only part of the right angle triangle, but also part of the larger triangle. So I chose to work with this one here. Could have also done it with the other side. And then once I find this side length, I can then go back and work with the right angle triangle. All right, that's it for this one.